Welcome to Real Physics. Maybe you know my series about great physicists, such as Einstein, Bohr, Schrödinger and Dirac, but there are many post-war physicists of equal merit, right? No. If you examine their theories, it turns out that those are totally incompatible with the picture of reality held by the founding fathers at the beginning of the last century. There is no way to carve both groups into a Mount Rushmore of physics. So I think it is time to call out the fallacies of modern theories, and Gell-Mann was certainly one of the key architects of what is called the standard model of particle physics. Now, one of the things Gell-Mann promoted was the classification of particles in a scheme defined by two axes, isospin and strangeness. This sounds very scientific, but at the end the two concepts are little more than neat names that cover up our ignorance of beta decay and its timescale. You can do math in such abstract spaces with symmetry groups, and Gell-Mann pompously called this the Eightfold Way, but it's worth remembering that Wolfgang Pauli described the entire approach as group pestilence. Then the story is told that Gell-Mann in 1961 had predicted the so-called omega particle. But if you look at the details, for example in the excellent book by Andrew Pickering, Constructing Quarks, it turns out that just an energy range was given that could be guessed from previous particles, such as the position of the next lamppost in the street. So you get the impression here of what the German physicist Lichtenberg neatly phrased: a part of the celebrity's glory is always due to the stupidity of the admirers. But Gell-Mann got the Nobel Prize. For what? He came to fame for his postulate of so-called quarks, hypothetical constituents of the proton. But again, if you look at history, the experimental evidence is very shaky. And it consists of little more than the fact that if you smash charged particles together, the result grossly deviates from the expected. Which is unsurprising, because classical electrodynamics just doesn't have a formula for highly accelerated charges. By the way, this is one problem swept under the rug by current theories, as thoughtful physicists such as Wolfgang Pauli always have admitted. Now, regarding quarks, the most bizarre thing of all is to call a particle something that is not part of anything. You just cannot divide a proton into its quarks. This is not linguistic nitpicking, but there should be a mechanism, a physical reason why the hell single quarks don't show up. There isn't any. In the worst tradition of bad philosophers, the absurdity is rubbed into a vacuous term, confinement. Add some hanky-panky explanation and that's it. David Lindley mocked the concept. In the end, the quark model succeeded by the ironical trick of proving that no quark would ever be directly seen by a physicist. This liberated physicists from any need to demonstrate the existence of quark in the traditional way. Nobody at the time, and even less Gell-Mann, seems to have reflected upon the grave epistemological defeat coming along with another complicating subdivision of elementary particles. The idea of quarks doesn't explain anything, let alone provide a revolutionary perspective. It is precisely such fake understanding that, without being testable by concrete observations, has eroded physics like a spreading disease. Richard Feynman commented on this group theoretical approach: there isn't any theory today that had SU3 times SU2 times U1, whatever the hell that is, that we know it is right, that has any experimental check. Now these guys are trying to put all this together. They're trying to, but they haven't, okay? So, while he seems to be refreshingly ironic about Gell-Mann's work, even Feynman later capitulated, complying with the zeitgeist and arguing we don't have anything better. There is much evidence in favor of the existence of quarks and little evidence again, so let's assume they exist. Does that sound enthusiastic? But even Feynman did not call out the bluff. One funny thing is that quarks were believed to have fractional charges, prompting experimenters to look for them. And when they came up with some evidence, theoreticians were not interested any longer. Gell-Mann shrewdly had assured himself of both outcomes by encouraging physicists to look for isolated quarks in order to demonstrate their non-separability. Think about that. In any case, he was to turn out either the prophet of confinement or the creator predictor of the new particles, a glorious role he surely saw himself in. Yet the unmotivated complication of the quark model does not stop here. To avoid contradictions, theoreticians, and again Gell-Mann played a major role, stated that all quarks must come in 3 colors, red, green, blue, which of course are unobservable, as are the auxiliary gluons, which must be imagined as having 2 colors. But they did not stop here. Extra rule! Every quark has to show up in 3 colors in a neutron or proton. You know, that's how it works in particle physics. They pull out an arbitrary rule out of their hat just to furnish it with a still more arbitrary restriction immediately thereafter. Thus, theoretical particle physics is brimming with such special laws, with special exceptions, symmetries that are asymmetric because they are broken, featured non-features, dry water and pregnant virgins. No question. Grown-up physicists like Einstein or Dirac would have been nauseated by such a mess. Gell-Mann, after his notorious quark proposal, continued pioneering the metaphorization of physics by linking non-quantifiable concepts to vague experimental predictions. He himself gave a telling account of that bizarre reasoning. We construct a mathematical theory of the strongly interacting particles, which may or may not have anything to do with reality, savor that, find suitable algebraic relations that hold in the model, postulate their validity, and then throw away the model. We compare this process to a method sometimes employed in the French cuisine. A piece of pheasant meat is cooked between 2 slices of veal, which are then discarded. To me, that is coquetting with insanities rather than doing physics. There was a time, probably Einstein and Dirac's, when the search for the laws of nature was a serious responsibility. Research is not a thing for brilliant idiots to play with. I'm not upset in first place because I think these theories are nonsense. It's the attitude of modern researchers that annoys me. Well, it could be nonsense, but we theoretical physicists are the brightest bulbs in any case. So what? The cover of Gell-Mann's book, The Quark and the Jaguar, calls him the Einstein of the second half of the 20th century. Gell-Mann wasn't beset by self-doubt when he swaggered about Einstein's failing ability when he was working on a unified field theory. Einstein was in fact 20 years younger than him when Gell-Mann was parroting the multidimensional fantasies of string theory. Not exactly something that makes you a second Einstein. So to summarize, apart from the fact that Gell-Mann contributed a considerable amount of nonsensical concept to what is called the standard model of particle physics, I believe he is also one of the main representatives of the smart but arrogant type of theoretician that caused the intellectual erosion of today now postmodern physics that has nothing to do with a honest search for the laws of nature. If intellectual brilliancy is combined with historical ignorance, the outcome is less than zero. Thus, I hate to say it, but Gell-Mann is one of the key responsible for the mess today's physics finds itself in. If you enjoyed the video, don't forget to like it, and if you're interested in real fundamental physics, subscribe to this channel.